The distributive property, day 2. Just like when we were solving equations by combining like terms, we still have 3 possible solutions. A reminder of what those 3 possible solutions are. We could have one solution, which is going to end, when we're solving it, we're going to end with x equal to a number. The number can be positive, the number can be negative, the number can be 0, but we end with a positive 1x equal to some number. We can also have no solution. When we have no solution, we're going to end solving the problem with a false statement. An example of false statements would be negative 3 equals 7, 2 equals negative 2, and 23 equals 0. There's tons and tons, infinite examples of a false statement, but basically it's setting 2 things that are not equal to each other. When we have a false statement, when we're done solving our equation, our answer is going to be that there is no solution. What that means is that there's no value for x that I can plug in and make the equation true. No matter what you plug in, the equation is always going to be false. And infinite solutions is our third possible answer. Infinite solutions is going to end with an identity. What an identity is it is a true statement, like negative 5 equals negative 5, 2 equals 2, or even x equals x. An identity is setting something equal to itself. When you have an identity when you're trying to solve an equation, your answer is going to be infinite solutions. What that means is that no matter what I plug in for x, the equation will always be true, or our variable. Our variable doesn't have to be x. So no matter what I plug in for the variable, that equation will always be true. There's never a number that you can plug in that makes the equation false. Our first example, when we're solving using the distributive property, these examples are going to combine basically everything that we've talked about with equations, so it's kind of a good review. The first thing we need to do, if we have it, is go ahead and distribute. In this case, I do need to distribute. I have 2 parentheses 4x plus 7 equal to 8x plus 14. So I'm going to go ahead and I'm going to distribute the 2 into both terms inside of my parenthesis. So 2 times 4x is 8x. 2 times a positive 7 is a positive 14, and I'm going to bring everything else down. So I'm still going to bring down equals 8x plus 14. If you look at this right now, I have 8x plus 14 equal to 8x plus 14. So I have the same things that equal to itself. Hopefully you're kind of starting to think, well, the same thing set equal to itself is the identity. Which means I have infinite solutions, and you would be correct. What I'm going to go ahead and do is I'm going to go ahead and I'm going to continue and get this problem down to where we either get rid of our variable or we have only variables left. So I'm going to go ahead and combine like terms. Remember, when I'm combining like terms and they're on different sides of the equation, I have to use inverse operations. So I have 2 positive 8x's on different sides of the equation. So what I'm going to do is I'm going to subtract 8x from both sides. And when I do that, it just so happens that the 8x's cancel out or equal 0 on both sides. What I'm left with is 14 equals 14. This statement will always be true. It's an identity. When I'm left with an identity, when I'm solving equations, my answer is that I have infinite solutions. No matter what number I plug in for x, this equation will always be true. The next example, I have 3x minus 7 equals 3 parentheses x minus 7. always check to see if you have the distributive property first. And in this case, I do need to use the distributive property. I need to multiply 3 times x. What I'm going to do is I'm going to go ahead and I'm going to bring down everything from the left side of the equation. And then I'm going to go ahead and multiply 3 times x is 3x. And 3 times negative 7 is negative 21. Now, hopefully you're thinking I need to combine my like terms. I have 3x on the left side and 3x on the right side of my equation. So what I need to do is I need to combine them or get them on the same side together. To do that, I need to use inverse operations because they're on different sides, which means I'm going to subtract 3x from both sides. Well, 3x minus 3x cancels, and this is going to happen on both sides because both sides have 3x minus 3x. And I'm left with negative 7 equals negative 21. Well, negative 7 does not equal negative 21, so this is a false statement. And when I have a false statement, my answer is that there is no solution to this equation, or there's no value of x that makes this equation true. The final example for this lesson, I have 4 parentheses 2 plus x, close parentheses, set equal to 4x minus 8. Just like in previous examples, because I do need to use the distributive property, I'm going to go ahead and do that first. So 4 times 2 is 8, and 4 times a positive x is a plus 4x, and I'm going to bring down equal 4x minus 8 because that's what was in my original equation. Just like in the previous examples, I have like terms. I have positive 4x on the left side and a positive 4x on the right side. I'm going to go ahead and try to combine my like terms, and when I do so, I need to use inverse operations because they're on different sides of the equation. When I subtract 4x from both sides, again, just like in my previous examples, my 4x's cancel out. Now remember, that's not always going to happen. I'm just showing you these examples because this is what the new information today is about over. When these cancel, I'm left with 8 equals negative 8. This example, or this statement is false. 8 does not equal negative 8. So my answer to this equation is that there is no solution. I did not do an example of one solution in this lesson because we've been doing one solution problems all along, and so I wanted to give you a couple of examples of infinite and no solutions.